Okay, in this video we are very quickly going to review multiplying and dividing fractions, which really should be pretty smooth because we don't have to worry about finding common denominators, but we will need to simplify when we look at our final outcome. Our first problem, what we're going to see here is that we can just multiply straight across. Our numerators, we have 2 and 4, so 2 times 4 is 8. And our denominators 3 and 5. 3 times 5 would be 15, and that's pretty much it on that one. There's nothing we can do to reduce, and so we move on. So our next one, multiplying straight across, 2 times 6 is 12, and 3 times 7 is 21. Now hopefully we can kind of catch ourselves here and see that we have 12 and 21 are both multiples of 3, so we can divide both numerator and denominator by 3, and I want to write that in here to remind you what we're doing. So 12 divided by 3 gives us 4, and 21 divided by 3 gives us 7. So that's that simplification process that you may need to do. Now it looks like I've copied the same problem here, which I have because I want to show you an alternate way. Previously, we were multiplying straight across here, and we end up with larger numbers that we end up having to reduce again and dividing again. So we're multiplying, getting big numbers, and then dividing to get smaller numbers. We can do that dividing right up front and just kind of reversing the order of what we're doing here to keep our numbers small. Just like here we can reduce 3 from both numerator and denominator, we can think of it before we get started that we can reduce 3 from both the numerator and the denominator level by reducing 3 diagonally here. So 3 divided by 3 gives us 1, 6 divided by 3 gives us 2. So we've done our simplifying step first. 2 times 2 gives us 4, and 1 times 7 gives us 7. So we end up with the same outcomes. That doesn't seem like a very big deal there, but as we get to more complicated problems, reducing first keeps your numbers small. So looking at this one here, I mean, who wants to multiply 6 times 25 and then 5 times 12 and then take those outcomes and try to find common denominators? We can reduce originally. So diagonally, we've got 5 and 25. We can say 5 divided by 5 gives us 1. 25 divided by 5 gives us 5. So we reduce that 5 from both numerator and denominator right out of the gate. We can do the same thing here. 6 divided by 6 is 1. 12 divided by 6 is 2. We end up with 5 halves. But we can also remember that we have a simplification skill here. This is an improper fraction. So we need to remember that 2 goes into 5 2 times with 1 left over. So our final outcome would be 2 1/2. Now in our next problem, we're multiplying 3 different fractions. So we've got 3 different sets of numbers that we need to think about common factors. Right out of the gate, we can see that diagonally here we have 3 in both the numerator and then the denominator, so we can reduce 3 from both the numerator and the denominator there, leaving a factor of 1. Our first and our third fractions involve a 6 and an 8, which are both multiples of 2. So we can divide both of those by 2. So 8 divided by 2 gives us 4. 6 divided by 2 gives us 3. I don't see any other simplifications that we can do, so I'm going to multiply across here. 5 times 3 gives us 15, and 4 times 7 gives us 28. And that's pretty much all that we need to review for multiplying fractions. Okay, moving on down to dividing or division of fractions. What we need to remember here is that you need to change your division problem into a multiplication problem. And we do that by, remember, stays, change, flips. So I'm going to write stays, change, and flip here, SCF, to kind of help us with that. I'm going to leave my first fraction as is. So I'll have 4/3. The change, we're going to change our sign from division to multiplication. And then we're going to flip the second fraction to make that 2/7. Okay, in other words, the problem dividing 4/3 by 7/2 is equivalent to multiplying it by 2/7. So once we've converted into a multiplication problem, it's really pretty easy. And our second one, again, I'm going to execute the stays change flip. But here I realize I can do some reducing diagonally. So I can reduce 2 from both the numerator here, and 4 divided by 2 gives me 2 here. And that will end up giving me 5, 6. Very often when we're dividing, we're going to find that there's usually not much simplifying or reducing that needs to be done. Okay, on a problem like this next one, a lot of times students have a hard time recognizing that this is really a division of fraction problems. They have a hard time recognizing this complex fraction, fractions within a complex fraction. But we can rewrite this as 2/9 divided by 5/12, and then rewrite it again as a multiplication statement. Again, executing the stays change flip. 2/9 stays, our sign changes to multiplication, and we flip that second one to 12/5. And then we look diagonally that 9 and 12 are both multiples of 3, so we can divide. 9 divided by 3 gives us 3. 12 divided by 3 gives us 4. So we can multiply straight across. We end up with 8/15. In our next problem, we just need to remember that we can write a whole number by writing it over 1 and then doing what we need to do here. 7/8, and then we're going to do the change to multiplication, and then 1/14. And we could go ahead and do reducing diagonally. 7 divided by 7 is 1. 14 divided by 7 is 2. And that leaves us with 1/16. Same thing going on here. I can change my problem into a multiplication statement. 36 over 1 times 5/4. 4 goes into 36 9 times. 4 divided by 4 is 1. 36 divided by 4 is 9, however you want to look at that. And then 9 times 5 gives us 45. I don't want to take the time to do these other two problems because they're very similar to the first two, but I would like to go ahead and go over these last two, which I've realized I forgot to include this in this lesson, that when you are multiplying mixed numbers, you need to convert both of those to improper fractions to carry out the multiplication. So in this case, we're going to say we're going to convert 2 1/3 to an improper fraction. 3 times 2 gives us 6, plus 1 more is 7/3. Our sign is not changing, it's still multiplication. 5 times 1 is 5, plus 4 more would give us 9/5. You can do some reducing diagonally here. 3 divided by 3 is 1. 9 divided by 3 is 3, and then multiply straight across. So we would have 21/5. And we could reduce that. That 5 goes into 21 4 times with 1/5 left over. Now let's say that I'm going to take 5 1/5, and I'm going to divide by 1 2/5. Let me divide this up here. I need to rewrite this as a improper fractions. Actually, I might do it this direction here. 5 times 4 gives us 20, plus 1 would be 21/5. Divide by, I'm not going to do two things at once here. Right now, all I'm doing is converting both of these to improper fractions. So 5 times 1 is 5, plus 2 more would be 7/5. And now I want to do my conversion, the stays change flip. So that would be 21 over 5. I'm converting the whole process now to a multiplication problem. So my sign is going to change to multiplication. I'm going to say 5/7. And I can see that 7 divided by 7 is 1. 21 divided by 7 is 3. I can reduce the 5's diagonally. 5 divided by 5 is 1. 5 divided by 5 is 1. When I'm multiplying straight across, this outcome comes out to be a 3. So I just wanted to review and include the idea that in order to multiply or divide mixed numbers, you need to convert all numbers to improper fractions so that you have that in fraction form to do your cross reducing.